All right, welcome back. This is the second video in our materials parsimony discussion, understanding the importance of materials parsimony. So we're going to talk about materials proliferation. I introduced it in the last time, and we're at the point now where materials proliferation is too much of a good thing. And it is we're at the point now where we have more chemicals and more innovation around materials than we'll ever need. And there's actually producing now, we're becoming increasingly aware of the negative consequences of materials proliferation. So this all got started back in the 1960s and is really captured, in DuPont's tagline or its motto from then at that time: better things for better living through chemistry, right? So DuPont actually was then a leader in this, and this was the chemical, the chemical innovation boom, for lack of a better. Chemistry was the high-tech industry of its time, and these innovative companies produced a lot of really fabulous materials, and we have to admit that we have benefited dramatically from all of these new and unique materials. But there are consequences in the fact that these new materials came with unwanted surprises. Our ability to innovate and create new materials is much faster, moves much more quickly than our ability to understand the consequences, both environmental and human health consequences of those materials. And it is guaranteed that we're producing stuff way before we know if there's anything negative that might come out of it. And it's taken a while. I began my career back in the 1980s investigating this. My job was as an environmental consultant, and I was working on remediation. Remediation is when you go to a place that's been contaminated by industrial chemicals, try to understand the extent of the pollution and try to clean it up. And my first place I started working was Silicon Valley in California, near the San Francisco Bay Area. Now, Silicon Valley is the home of these high-tech computer manufacturers and chip makers. And at the time, everyone thought that this was the clean industry of the future, right? Because if you go to Silicon Valley, you don't see big factories with giant smokestacks belching out pollution constantly. What you get to see are these very nice, well-groomed and manicured corporate campuses, right? But behind the scenes of those, behind the facade of those corporate campuses, the truth was the manufacture of these high-tech products required a lot of really aggressive chemicals. There were a lot of sort of highly toxic solvents. There were acids. There were all kinds of materials that were used that actually turned out to be quite toxic. And through mismanagement and otherwise, a lot of these toxins got out of the plant and they got into the soil and into the groundwater. And our job was to go figure out what the extent of the pollution was and try to clean it up. Now, what you learn very quickly when you do that is that this is a very difficult job. If you've ever squeezed too much toothpaste out of the toothpaste tube and then try to get it all back in, you can never get it all back in. And that's sort of the same thing here. Once this pollution gets out into the environment, it's very hard to get it all back. And it's really important because a little bit is a big deal. These things are highly toxic at small concentrations. So we were trying to clean up these sites to the parts per million, parts per billion level, which is the equivalent of, say, a small Dixie cup of a chemical poured into an Olympic-sized swimming pool, for example. So this was a horrendous job, and it turned out to be a real challenge. And a good example of the consequences we are now discovering of this materials proliferation and this innovation around aggressive synthetic chemicals is DuPont. Again, DuPont was a leader here, right? They were sort of the high-tech company of their age, the innovative, high-tech, fast-growing company of their age. And they produced a lot of really dramatic chemicals, some with really interesting properties. So, for example, there is a family of chemicals, perfluorooctanes, or PFSs, we'll call them PFSs. They have these really nice properties. They don't break down in the, in the normal atmosphere where we live. They're not broken down. They're synthetic, so they're not, bacteria and things don't break them down in normal. So they're stable down here in the lower atmosphere. They're also, very resistant to high temperatures, and they found these really kind of convenience serving applications. So Teflon pans, for example, use PFOS to make them non-stick. Another example is things like Scotchgard or stain resistant. 3M produces Scotchgard, and it uses these PFC family of chemicals. Now this is an interesting example because what happened was they had been producing this for many years, and in 1997, the the health and safety scientist at a 3M plant that was producing these PFC chemicals did a routine check of employees' blood, and they sampled all the employees, and as expected, in the blood samples of all of these employees, there were small concentrations of these PFCs. So because they were constantly exposed to it. But what was sort of interesting and disturbing was the doctor also got samples from people that had never been to the plant as a control group. You need a control group that's clean so that you can make sure that your chemical equipment is working good, your scientific equipment. Well, when he tested the blood of these people that had never been in the factory, he found concentrations of PFCs in their blood and tissues. This was really disturbing, and he thought there might be a problem. So he went to the Red Cross and got 600 samples from blood donors across the country, tested them all, and found PFCs in all of them. So now he was really disturbed, and he said, well, okay, let's get far enough away. So he went and got samples from Europe and other countries and found PFC in those people's blood as well. And it turns out not just humans in industrial countries. PFCs is found everywhere. It's found in tissue samples from walruses in the North Pole, from whales in the South Pole. PFCs are found in almost every living thing on the planet. It's inescapable. Now, he was shocked and worried about this and called this attention to 3M executives. And to their credit, when the 3M executives actually evaluated this situation, they decided to shut down their factory that was producing these PFCs. And that happened about a decade ago. And so they did this. You could say they did this because it was the responsible thing to do once you discover that you've put chemicals in the tissue of every living thing in the planet. But there are also business reasons for doing so. As part of the Superfund rules, there is something known as joint and several liability, which basically means that any company that has used, or touched a chemical that is shown to actually be the cause of pollution in the future can be held for the entire cost of cleanup. So the manufacturer of the chemical can be held responsible. A supplier that uses that chemical to formulate it into a new chemical compound, they can be held responsible. If they sell it to a company and the company uses that for the manufacture of product, they can be held responsible if that product gets disposed of by another company. And so everybody who touches that product can be held responsible for the entire cost of cleanup. So think about this from 3M's perspective. If, as some scientists suspect, PFCs cause human health problems, if they're discovered to cause human health problems or they're discovered to cause birth defects or something, what is the cost of trying to clean up a chemical, to remediate a chemical that's found in the tissue of every living thing on the planet? Absolutely astronomical, right? So just for risk reasons, 3M got itself out of this, and arguably also because it was the responsible thing to do. DuPont, however, didn't. DuPont actually continued to produce these chemicals well into the future, and only very recently did it stop producing it because it was forced by government regulation to halt the production. The EPA has now basically outlawed the production of these chemicals. So DuPont is now has a real challenge, and you can see how it understands the risk by the actions it's taken recently. Recently, what it's done is taken all of these manufacturing facilities, these factories, these plants that were producing these types of chemicals and other risky chemicals, and it has packaged them up and then has rolled them into a new company that it calls Chemours. And so DuPont no longer owns all of these assets that produce these potentially high-risk, very risky chemicals. Now we'll see what happens. We'll see if this allows DuPont to clean itself and remove perhaps the responsibility, if it can pass all that responsibility off to Chemours. We'll see about that going forward. This is a very recent, as we speak, this is going on. Investors are not very confident that this is going to work, but we will see. But you can see, trying to get yourself get that risk burden, take it off and pass it on to another company is an indication of the unwanted surprises and then perhaps the unfortunate delay in DuPont's reacting to the science around their chemical. So this is an important sort of outcome of materials proliferation. We're discovering increasingly the unwanted consequences that came forward, and it's led companies to begin to realize that they can't take what a company like DuPont or anyone says about the safety of their chemical on their own. They need to begin to inform themselves as manufacturers. And I've spoken to a lot of executives about this, and one company executive put it nice and succinctly, said, it's no longer acceptable to us to use materials without understanding their full impacts. We want to know what's going into our products. And in the next video, we will see an innovation, an approach that allows companies to begin to get a handle on it, a strategy by which you can begin to take into account and understand the impacts of the chemicals in your manufacturing process.